Okay, so this is 4.6, number 13. The question is, an airplane is flying at an altitude of 7 miles and passes directly over a radar antenna. When the plane is 10 miles from the antenna, or S is 10, the radar detects that the distance S is changing at the rate of 300 miles per hour. What is the speed of the airplane at that moment? So first of all, you have to think about what the question is actually asking. And if you think closely, you'll realize the speed of the airplane would be the distance that is changing. So we're looking for dx dt. And the first thing we have to do is get out our toolbox. Okay, so the diagram from the book is here. You have to think about what you know first of all. So you know that since this is a Pythagorean triangle, that 7 squared, or the altitude, plus x squared, or the leg, equals s squared, or the hypotenuse. So we write that in here. And then we also know what the question gave us, which is that ds dt equals 300 miles per hour when s equals 10. So we write that in our toolbox also. Okay, and then we can go down here and solve the Pythagorean triangle. So we know that is always going to be 7. The altitude is not changing. And we know they gave us that s is 10. So the theorem is a squared plus b squared equals c squared. And then we can plug in the numbers that we have, which is 7 squared plus x squared equals 10 squared. And then we can solve for x squared. So we get x squared equals 100 minus 49. And then you can solve for that and get x squared equals 51. And then if you solve for x, you get x equals radical 51. So that's the value of x there when s equals 10 and the altitude is 7. So we can put that also into our toolbox since that might be useful later. So we know x equals radical 51 when s equals 10. Okay, so now that we have our toolbox ready, we can start to derive it. First, you have to think about what you're seeking. And we said already that I seek dx dt, or that the distance that's changing, which will give us the speed of the airplane, when s equals 10. So we can start by using the formula we already have in our toolbox, which is 7 squared plus x squared equals s squared. And remember that you don't plug in the s value until the end, since that might screw up our result. So if you derive it, 7 squared is 49, but because it's a constant, its derivative is 0. So we get 0 plus, and then the derivative of x squared is 2x multiplied by dx dt, since you have to do the chain rule, dx dt, and then the derivative of s squared is 2s times ds dt, because you have to do the chain rule again. So then from there we can plug in the values that we have. We have that x equals radical 51, we have that s equals 10, and we have that ds dt is 300. So we can do 2 times radical 51 times dx dt equals 2 times 10 times 300. From there we can cross out the 2's, since they cancel. And then we can solve for dx dt. So we get dx dt equals 10 times 300, or just this side, divided by radical 51. And that is equivalent to 3,000 over radical 51 in miles per hour. Remember, I always have to add the units. Okay, that's the problem.